Okay, so today we want to go over solutions to a compound OR and then also compare it to a compound AND. So remember, a solution to a compound OR, it only has to work for one of the equations, so at least one of the equations. However, a solution to a compound AND must work for both sentences. So let's compare. So where are all the solutions that are bigger than 2? So if we go above the number 2, open circle, all the numbers greater than 2 are to the right forever and ever and ever. These are all the ones that will make that first sentence true. And then where are all the numbers that are less than -3? That is from here to the left forever and ever and ever. So if you look at this first interval to the left of -3, notice that above it is blue. So that means that all of these numbers will make the second one true. So it may not make the first one true, but it makes the second one true. And if you look in between, the interval that's in between, notice that there is no color above that interval. So there's nothing that will make that one true. And then if you look at the third interval to the right of 2, you notice that it has red. So that means all of those are solutions. So your final answer should be all the numbers that are less than -3 will make at least that one true. And then all the numbers greater than 2 will make at least that one true. And that is your OR. Compare that to an AND. Let's do the AND. Here we want all numbers that are greater than -4, so above the number line. All the numbers that are greater than -4 are to the right forever and ever and ever. So this will make the first sentence true. So anything that is red will make the first sentence true. And then anything that is blue will make the second sentence true. So anything less than 8, so above 8, forever and ever and ever and ever. Now notice these numbers, there's only one color. And notice that these numbers to the right of 8 only has red. And if it's an AND, it has to make both true. So the interval that has both colors is the middle interval. So the numbers that are between -4 and 8, don't those have both colors? So notice this one only makes one of them true. Notice that this to the right of 8 only makes the red one true. And we want where it makes both true. So therefore, our answer is in between. And then don't forget that we have open circles. So you should have an open circle at the end and an open circle at the end. If those were equal to symbols underneath there, then those would have been solid. So let's try another one. Okay, so remember, if it's an OR, it only has to make at least one of them true. So where are all the numbers that will make the first one true, we're going to put in red. So any number that is greater than, so it's solid, or equal to, forever and ever and ever and ever, that will make the first one true. What about the second sentence? Anything less than or equal to 2 will make the second sentence true. So we'll do that one in blue, so it's a solid circle, and to the left, less than, forever and ever and ever, will make the second one true. Because this is an OR, it only has to make one of them true. So isn't this interval, this first interval, we call those intervals, right? We got the first interval, you got the middle interval, and you got the interval to the right of 8. Doesn't this one have blue colored above it? So that means anything that is to the left of 2 will at least make that second sentence true. Notice in the middle of the interval between 2 and 8, there aren't any colors. So there is nothing that's going to make those true, so those don't get shaded. And then to the third interval, notice it has red above it. So that means anything to the right of 8 will make this first one true. So our final answer is all numbers to the left of 2 will at least make that second one true. And all numbers greater than or equal to 8 will at least make that first one true. And then because there's equal to symbols, there should be solid. And that's what your graph should look like. Remember, for an and, we are looking for what numbers will make both sentences true. So any number in red will make the first one true. So any number greater than 4, so above the number line 4, forever and ever and ever, will make the first one true. And any number in blue will make the second sentence true. So above 12, put an open circle, and anything less than 12, right, will make that true. And notice that the numbers that are in between are the ones that will make both true because they have both colors. So it's going to be open circle, and this is where your final answer is going to be. So that should be your final answer. So we shade above to kind of help us figure out where they overlap, where the two graphs overlap. Now let's look at some special cases. So let's go do some special cases. Okay, let's look at these two cases. So once again, for an or, as long as it makes at least one of them true. So any number that is greater than 4 will make the first one true. So any number that is bigger than 4, forever and ever and ever, will make the first one true. And any number that is less than 10 will make the second one true. We're not looking where they overlap. So this one's a little bit more challenging. So basically, we're going to do it again, but this time, right? So anything to the right of 4 will make the first one true. And anything to the left of 10 will make the second one true, forever and ever and ever. So what happens is the whole entire number line is actually shaded. So we have to, our final answer has to be all real numbers. So you can say ARN, you can spell out all real numbers, or you can use fancy N, or you can say N is an element of the real numbers. So this is the fancy notation for all real numbers. So either one you can write, but it turns out being the whole entire number line. We're not looking for where they intersect because it's an or. So as long as it makes at least one of them true. So let's do that one again. So usually on the ors, normally when I'm doing the ors, I don't do above the number line. I just put them on the number line. So again, any number that is less than 10 is from here forever and ever and ever and ever and ever and ever. And then anything that is greater than 4 is from 4 forever and ever and ever. So it fills that in, and you end up getting the whole entire number line. So that's a special case. For an and, I like to do them above the number line. So any number greater than 2 is above 2 forever and ever and ever to the right of 2. And any number that is to the left of -1 makes the second one true. So anything to the left of -1 makes that true. And remember, for an and, we're looking at both. And notice that this interval only has one color. This interval has no colors. And this interval only has one color. And we're looking for both. So there is no overlap. There are no intervals that have both colors. In other words, think about it. Can you give me a number that is bigger than 2, but also a number that is smaller than 1? Say that again. Can you give me a number that is bigger than 2 and at the same time smaller than -1? And there's no way that you can do that. So this one, your final answer has to be no solution. Okay, let's go through and solve some sentences and then graph. Well, before we do that, let's look at the other special case. This is called a between statement. And you can read this two different ways. So you can read this numbers that are between, so use the word between, -4 and 5. So you can read that numbers that are between -4 and 5. You can also read this as all numbers that are less than 5 and all numbers that are greater or equal to -4. So you can read it two different ways. Are you wondering how we got this one? All numbers that are less than 5, isn't that this part? And then if you read this one Hebrew style backwards, sorry. If you read this one backwards, n is greater than or equal to -5, there's that one. And this is an and. This is an and. So again, I like to read it this way. I like to read this as all numbers that are between -4 and 5. So when you go to graph it, just graph -4 and 5, and we want all numbers that are between -4 and 5. And because there's an equal to symbol underneath there, it should be solid. And that's how you graph that. Okay, let's solve some equations. Okay, so when you graph this, first you have to solve. So don't we need to multiply both sides by a -2? And because we multiply by a negative number, doesn't the reverse rule apply? So the reverse rule applies. I want you to do that on your homework because I want you to emphasize when the reverse rule applies. We're going to add 5 to both sides, and we're going to bring that down so it's nice and neat on the same line. And you must write your OR in your final answer and box off your final answers. And it should be on a nice straight line. So if you rewrite it, rewrite it. Then we have to graph it. So because it's an OR, it only has to work for at least one. So all the numbers that will make this sentence true are all the numbers to the left of -8, or all the numbers that will make the second sentence true are all the numbers that are greater than or equal to 1. And that's your answer for that question. Now let's look at a between style and. So let's look at this between style of and. Now, some videos or tutors will tell you just to rewrite it as two separate with the word and in the middle. And I'm not going to give you credit if you separate it. We want you to learn how to solve a between type of an and problem without rewriting it as two separate problems. So I will not accept if you rewrite it. A lot of the apps that you take a picture of, it'll show you to separate it. So I will not accept that. So to solve a between type and, you're really just solving two inequalities simultaneously. So maybe highlight or put a line through those two problems. And then you have the middle. You can think of this as the middle. And you have the two ends. And whatever you do to the middle, you have to do to both ends, because you're basically solving this inequality, and then you're solving this inequality, and we're just solving them simultaneously. So we're going to undo adding 1 by subtracting 1. So if I do it to the middle, I must do it to both ends, and that's what your paper should look like. Doesn't that leave me -7 on the left side? That zeroes out. And doesn't that leave me 4 on the right side? Then, because I'm dividing by 2, I can multiply 2 to the middle, so I have to multiply by 2 to both ends. So that gives me -14 is less than x is less than 8. And then I can graph it, because this is red, all numbers that are between -14 and 8. That's what that means. All numbers that are between -4 and 8, and they're open circles because there's no equal to symbols. If there had been equal to symbols underneath there, then I would have shaded the ends, right? So that's how you solve a between type of an and. Do not separate them. Go back and rewatch the video for homework 20, and it shows you and does more practice problems with that. Right? So hopefully this is enough to show you how to solve ands and ors and graphing. Have a good day.